today we'll have our presenter, Amit Bender. I hope I pronounced that correctly. And he's a AI and machine learning expert, and he will have a talk about ML DevOps best practice. And he's promising us that it will not be just another presentation. So let's go a bit over the meetup in general. We'll start with the presentation, and afterwards, Yelena will take over, and then we can have a discussion about different topics, whatever people might want to bring up. Yes, hello. Yeah, and yeah, afterwards you can leave your feedback about the talk, how you liked it, and if you wish to talk in this event yourself, then feel free to get in touch with any of the people who are in the Techies of Baltics Slack channel, or you can get in touch over DevOps LV. There are different ways, or just ping one of the people who are organizing it. So I guess I covered the agenda for today. Without any further ado, I'll give the word to Amit, and let's go.
Thank you very much, Edgar. Let me just share my screen in a moment. All right. Okay. Hope you guys can see. Okay, so thank you for joining to this talk about MLOps, which is some sort of combination between DevOps and maybe the engineering side of machine learning data science. This talk is originally intended for data scientists, but don't worry, I get you covered with some explanations. If you have any question during the presentation, so just feel free to stop me, and I will try to do my best to explain a few things. And this talk is not going to be, as you see, another like best practices talk about this is how you should do things. This is not. And here I'm going to actually share just the story with you of our journey in Artlist. I'm the head of AI data science at Artlist, and how what we learned during this journey, how is it working for us, and how practically you can go forward and do and implement things with your data science teams as maybe as a DevOps. Okay, so the story is starting about like a year and a half ago. I was sitting in the office, not like here drinking whiskey, but just starting the department, and I was the first employee. And I had some time to think with myself after managing a few data science teams, after seeing success stories and failures. What will be the best way to build it right this time? You know, this feeling when you want to do it right, when you just start and you have all the motivation, and it all started back then. So, so what are we going to talk? I'm going to talk about today. So we'll share our journey, as I said, and then while starting this journey into MLOps, I started to build a vision, and then you will see from this vision of values and all kind of different high-level talks how we actually found the way to implement it. And I will give more than a few real-life examples for that. So just a few words about myself. So as you see, my name is Amit Bender, and I currently work at Artlist, as I said, at the head of AI and data science. I'm also a podcaster and a lecturer, as you can see from the different images. I used to be a CDO in a few startups. One of them I founded myself, called Gooster, natural language processing, and also software development and architecture. And I have this broad knowledge of all these different terms, what brought me to this position today. And about the company that I'm working in, Artlist. Some of you might have heard the name if you're in the video industry, and if not, same as myself. So it's a company that is already 6 years here and already have 4 products and content and tool for creators. So just to a good examples to show what Artlist is doing, and this is only, of course, just for the background. Artlist is providing assets for video creators. What does it mean? Let's say I want to be a YouTuber, and starting to be a YouTuber, I downloaded some editing software. I created a video and it's all looking great, but there is silence in the background and it sounds horrible. And I'm also a fan of the Red Hot Chili Peppers, for example. So I put the music inside and then I upload it to YouTube, and then bam, I'm getting rejected. This video is has a copyright infringement because I'm using this Red Hot Chili Peppers music. So exactly from that, Artlist started, and Artlist providing a subscription where you can buy different assets, starting from music, afterwards sound effects, videos, and other things. So there are a few different platforms focused more on videos, templates, and even in editing software, 2 companies that were also acquired recently. So that's just for the background, and this is how it looks like. As you can see over here, there's a few AI features such as a For You, we'll talk about that, and some other cool things. So again, for the background, we're a team of 7 today. As you see, 1-year-old, maybe a bit more. The department ourselves was still pretty young, pretty small, but we are working with the different teams in the company, and we're trying to be the tech innovators. We are working with a lot of different data types. So it means video, audio, text, a lot of different things. We work in multi-cloud. So it's GCP, Google Cloud together with AWS. And that's, of course, imposing some challenges. And also we're using data warehouse, Snowflake, and data lake as primary sources of data. Okay, so what are we actually doing in day-to-day? We are building some personalization features, search features, content features such as analyzing content, creation, stuff like that. And we're doing predictions on which users are going to leave, where to use our money, a lot of data science things to optimize what we're doing. So because I know you guys are coming from DevOps, I will just try to give you a bit of an overview about the data science process, just so you understand what I'm talking about in general, because I might mention a few things. So data science has a circle where you do experimentation. It means you do some research and you try to get some data, you train a model, you do all kind of different things, and then you need to go to production, and that's a whole different stories that you guys fairly know, when you need to wrap up the services, deploy, scale, monitor, and all of that. So this is how the data science cycle looks like. Also, if we're talking about the process of data science AI, in general, how it looks like. So what's different from AI, from software, different usual software engineering, is that we try to train it to learn by itself and not give only instructions. It means that we're collecting a lot of different examples. We are doing some training. From this training, we create something called a model that afterwards we can run some examples into it and get predictions. For example, we can get input a lot of text, different text parts, and see if it's fake news or not fake news after we're doing the training. So that was a long background, but now we're going a bit deeper into our talk. Okay, so first of all, I want to tell you back then to the story, me sitting alone, no employees in my department, thinking how to do things good. So for that, I started to think about what are my actual ultimate goals when I'm building the department. So the first one is to bring impact, and that's, of course, business impact. It's something that all of us want to do. And for that, there are two conflicting values that I started to notice. So the first one is that we're trying to be independent. It means that we want to work alone, basically, and try to have as little as possible dependence on different departments such as R&D. And even in terms of DevOps, we want to have the tools, but not to have to get some help all the time. We want to have a good infrastructure and not to have to get some help and a blocker from different people in the teams. So this is one very important value. And the second one is that we want to focus on data science because it's really easy to do a little bit of backend, a little bit of front end, a little bit of DevOps, a little bit of other things in order to make it work. So those two are obviously conflicting, and that's not the only conflict that we have. And I think we started to understand that, and we understood that it needs to be a balance between those two. And I will show you the balance that we found. So the approach that we decided is called up to the API, which means our team is going to do no front end or back end work, which is not related directly to what we do. And also in terms of data, we're not going to do data engineering. What we are taking under our ownership is everything from that's related to the models and the things that we are working on, which means building the pipelines that are gathering the data, that going to do the pre-processing. It means training these models. It's not that you train it only once, you have to retrain it every time. And also the inference, which is the part when you already have the model and you need to push data inside and get the predictions back. And we're doing it through a simple API and using Docker. Okay, so as I promised, now we're going into these values. So I start and say, as you said, it sounds like very vague and idealistic. But I will show you exactly how we took all this decision and all these values into actual decisions that change everything in our day-to-day. And I must say, you can see that every new employee and every person that is joining the department, after learning those, it's much easier to take decisions. So I really recommend. So with a little bit of inspiration from our company, we're starting with enabling creativity. So what do I mean by that? So we wanted to have max flexibility in the research, which means when you do research, you want to open your mind as much as possible. You don't want to be caged in some tools or things that you want to have. It means that if you're using different, you want to use notebooks, we're working with Python mostly. If you want to use notebooks or you want to use scripts, you should use whatever you'd like to do. Also, if you want to use your framework, if you guys heard about TensorFlow or PyTorch or sklearn or all different frameworks that data scientists love to work with, you want to enable data scientists to work with whatever tools they want to. Okay, so this is the first thing. The second, and again, here's another conflict, as I said, we're good with conflict, is simplicity, but keep focus over here, because with simplicity, it's pretty much the opposite of flexibility that we talked about in the research. But here we're talking about taking the opposite direction. And in the research, we want the maximum flexibility. When talking about the engineering part of data science, we're trying to have the minimal flexibility. It sounds horrible, but let me explain you why. When working on data science, it's already complex. You're already doing all the math, all the different things. And when you leave data scientists, which are not really good at doing engineering, let's be honest. It means that you might get some really poor results. For that, we're trying to give as many built-in solutions, good solutions, robust solutions that are already there. So as I like to mention, our focus and where we bring most of our value is with the areas of research and not the engineering. The engineering only needs to serve the research so we can get some really good model out there. Another thing that we're doing with simplicity, we have only one implementation. What does it mean? It means that we have a few different component things that we're working in, which is pipelines. And I will show you later how it looks like. API, where you try to externalize your model and to get predictions back, and Python packages. So there is only one way to do it. For example, when you write an API, it's always with Fast API and not with other tools. So that's just one example, but it can be other things. And we want to write as much as of the boilerplate and all the wraps that we need around this to keep things the same way. So once the data scientist is starting to work on that, there's no much room to be wrong or need to write extra things. So for that, we have templates that we developed. In Python, they call cookie cutter, and I'll show how it looks like. We have a library called standard operations. Just a pick for that, we put inside all the must-haves that we must have inside, such as configuration, logs, and other things. And we keep everything containerized just to make sure that we can run this workload wherever we want, whether it's an API or batch or something else. Okay, another value which is super important is transparency, and that's also an interesting approach that we took. What we thought about transparency, it means that we want to take code or infrastructure or whatever we need, so we'll have the least interaction with it. It means in terms of infrastructure, I wrote no DevOps. What we want to get to is a position where after building the whole pipeline of things, I don't want to wake up the DevOps in the middle of the night or someone from our team, just to have everything already there, all the tools written, so it will be easy to deploy these complex workflows. Besides that, also, when looking even in a bit micro, even a bit deeper, when looking at even Python, our Python library, such as this standard ops, with standard ops, we took all the libraries and all the implementation where you don't have to do anything but just import log, import configuration, import tracking, and you have everything set up. If you'd like to tinker it, no problem, but try to keep it as simple as possible. Also, we're doing tracking of everything that we do. It's a common practice in MLOps, where you try to track everything that happens in order to see how the experiment is going. So we want everything that can work behind the scenes. So for that, we chose only managed services as much as we can that are also serverless, and other different kind of tools that are fully managed in a way that we don't even know that they are there. We don't have to think about cost or maybe to whether the machine is working or not, or something like that. And the last one, sorry, is the robustness or well-engineered. We believe in code quality, test, and data validation. Those are super important things that you know that are pretty obvious in the engineering world, but not in the data science world. So it means that we want to have, of course, the unit tests and things like that, but also make sure that the data we're receiving is actually good data, and also the predictions that going outside actually make sense. We're always trying to choose production-ready tools, cloud-native tools, and to have a full CI/CD pipeline. And for data science, as I already mentioned, monitoring is super important in every different part of the process. And we try to reduce production risk as possible. And we're doing that, but by running batch when we can and not real time, because as we said, we're not the best engineers, and then it's much easier to put it on something that can be down for at least a few hours with not us having to jump fast. So those are the three, as I said, enabling creativity, simplicity, transparency, and the robustness and well-engineered. Okay, and now we talked about the general things. Here it's a meme in Hebrew, which says, the management is congratulate me how well is the model, and then I did some mistake on the data, so just a dead joke over here. And let's look at the implementation and how we took all these great ideas into actual decisions to make our data science team agile and work well. So as I said at first, we have our first implementation is this templates, and we took the framework called Cookie Cutter to create this templates for us. And the good thing about that is Cookie Cutter allows you to just run like a simple questionnaire with all the data that you need, and then you can, it will generate for you the project with all kind of different parameters inside, standard ops and experiment tracking. Okay, and we'll get into each one of those, but we'll start with the pipelines. So over here you can see how the cookie cutter look like. You just run basically this command cookie cutter with a URL to the specific cookie cutter project that we created. This one was specifically for Vertex pipelines, which is one framework for building pipelines for machine learning. And maybe I would just explain for you guys that many different frameworks, it makes sense when you do data science to cut them into components and in a pipeline, because usually those are batch jobs, and also there's a lot of repeat. And when you build those kind of components, so you can, when you're cutting nicely the different components, you can reuse them in many different ways. So coming back to this example, you can choose whether you're going to build a whole pipeline or just one specific component. You give it a name, you choose the product, a description, region, and all kind of different things. And you're going to have a template of code of everything that you need, and at least one component, which is going to be with all the boilerplates. So you're going to write it fast and robustly. Also, this is how it looks like afterwards. Also, we used something called NVRC, which also allows us to jump back between different virtual environments, and a make full of nice automations that our ML engineer created. So as you can see over here, we said simplicity. This is one example for how we implemented simplicity in a way that we just getting started. You don't have to think too much. Everything is in the right place. You get the configuration ready. You get a component ready. You just need to add the code inside. You get all the different boilerplate and the automations and everything inside, including CI and other things. Okay, now let's talk about this standard ops that I mentioned before. So I know you guys probably know you've done something similar, but inside the data science world, you don't have sometimes all the tools, all the things that you need packed up. It's because, you know, it's not an engineering centric usually teams. So we thought about how we're going to put something that every piece of code that we're creating is going to use and is crucial to the run of this code. So first of all, we thought about one of the things that we have a lot in data science project is configuration, because you're going to create models, different models that are going to be changed just with one parameter or something like that. And you want to manage that fairly nicely. You want to have a cascade of configuration, which means you can override configuration from the outside as you go, and all these different features with environment variables or any other thing. Also, we want to have logs when we're working on our own machine. So it's going to be fairly simple, nice logs, but when running on the cloud, you want to have structured logs that looks nicely. So we chose a struct log. This is one other library that we use. Another tool which is very nice, but there are many of those outside for MLOps is called ClearML. And ClearML gives us tracking. So as I said, once you install that, what's going to happen when you start a new task, and then it starts to send telemetry to the server. But this telemetry is not so much about the machine itself, but mostly about everything that you do with the experiment, such as you can go back and understand what you do. Because something that happens to data scientists all the time is that you run some experiment with some parameter because you had some idea that might work when you develop the model, and then you go 6 months afterwards, or even just 2 weeks, and you just forget what you've done. And it's really hard to, to run those experiments, because training can take an hour if it's a small one, but it can take also like a few days or even months to train a big model. And you want to make sure you know everything that you did and you're learning as you go. Besides that, we have all the secret management and all of that. So this is what you have in this simple standard ops. And let's look at a few different parts of how it's actually implemented. So first of all, this is the configuration. So as I said, we use a library called a DanaConf. So you basically just write this different TOML file, and in this TOML file, you can have like the name of the project and all kind of different things that you usually needs to use. And the nice thing over here is also that you can have different configuration for different environments that is pre-baked. Here you can see the default, but you can put also some other parts of configuration that is going to be running only in a specific environment. Sorry. So this is how it looks like in the real world. You just import CFG. So I know it might look a bit weird, but you remember transparency and simplicity. This is exactly it. You just import that, and then you have this global variable holding all the configuration inside, and it's super easy. You don't have to configure anything by yourself. You just import, and that's just working by itself. And I can tell you that's working fantastic for us. So that's just one example. Okay, so we talked a little bit about experimentation. So when running with experimentation, when you just try to do a bunch of different things, you want to work with some tool that will help you to do that. So we allow our guys to work with different libraries such as Plotly for visualizations, and running together with buckets and other tools, also working with notebooks such as Colab and others. And even when you want to go into production, you're usually going to deploy it into Kubernetes. Okay, so something we're doing is tracking, as I said, tracking everything that's happening in our code. So for that, as you can see, you just need to run those two import and this command, and then you're going to just start tracking everything without you being to have to add anything inside your code. It's going to track automatically everything that you do. So we wrapped up this service called ClearML. It's possible to do it also with MLflow or weights and biases or any other kind of service, and to just run this start tracking, and then it's going to log every line of code that is running. It's going to log what is the Git branch that you're working on, where is the repository, and all kind of different results, because it's already knowing those frameworks and know how to log almost everything automatically. And this is, by the way, how it looks from the other side. You can just see all the results, plots, and other things in this service called ClearML. As I said, it's open source, so it's really nice, and you guys can just play with it pretty simply. Okay, so we talked about experimentation and general things, and now when going into production, that's a whole different level of complication, as you know. And it's super important for us to get the impact, and this is the way that we're doing that. So moving from doing flexible, whatever we want to do, here we try to make everything in a way that is going to be robust and production ready. Okay, so when going to production, as we said, we're going to use tools that we trust. We try to use those managed tools, cloud native, and as you remember, the API is the limit. It means that we're going to write the API only by the API and not the front end or the operational parts of this service. And let's take for an example a feature that we created, which is called Similar Song. This is an AI feature that once you have a song that has a lot of different features, such as sorry, the genre or the mood or some other things that we have internally that we manage to collect. And we try to create some prediction, what are the most similar songs for that. Sorry, 1 second. So this feature was released something like 6 months ago, and it's running on batch, and every few hours we're creating all the similar songs for the whole catalog using this AI algorithm from behind the scenes. So how does it look? Actually, it looks like, starting with a scheduler that is going to trigger some cloud function. And this cloud function is going to run the pipelines and say the pipeline, hey, run right now with this configuration. And this one, the pipeline is always going into different data sources, such as BigQuery or Snowflake or other data warehouses, the buckets, and the results eventually are going to be stored into the Google storage, and the model that was trained at the end is going to be accessible through a FACE API. As we talked before, every part over here is pretty much not flexible. Okay, we have one way to do all of this. We're trying to have one way, and it's working for us pretty well here. Although there might be a better way, but as I said, we're trying to keep it as small as possible in the engineering side. Okay, so as you can see, this is how it looks like with the Vertex AI in GCP. Every run is going to get into this kind of visualization. We're going to see the status, and the pipeline is composed by a lot of different containers that are running. Okay, so one concept which is super important when going to ML pipelines, and I talked a little bit about it, it's a bit like a Lego. And to use it very well, the way to do it is by understanding that you need to build all the components pretty general. Like, for example, the process that's usually being done in AI is that you first pull the data, maybe from a few sources, you then process it in a way, and then you start to model it, train the model, and then create the predictions and deploy it. So a lot of things are actually almost the same from different pipeline to pipeline. And when you build it right and you write it in a way which is loosely coupled and reusable, you can save a lot of time. So let's see an example with our pipeline, but maybe first just let's talk about what are the things that we're looking when we're trying to build these different components, these different blocks. We want each one of them to have a single purpose, as you know, such as with microservices. We want to make sure that they are generic and reusable as much as possible. Of course, they should be containerized, and they should be pretty uniform and predictable, such as it's pretty simple to understand how they're going to work if you change a few parameters. And now to the interesting part. So this is how a pipeline looks like. So as you can see, that it would take in some data from a few different data warehouses, and then we save this data into a bucket. After sending them into a bucket, then we read it again, we process it again, and then save it into some intermediate object. Afterwards, we're going to do all kind of different predictions and bring the best list, personalized list for every song. For this, it's like the most similar song for each one of those. Do some business filtering, and then upload those lists back to whatever they're going to be deployed at. So that's what's going to happen. So as you can see, that's a few containers. We have different pipelines with even hundreds of different steps like this. But you can see over here how we made this process so much simpler because we reused a few different things. So data extraction is something that we do all the time. So we just get a configuration of an SQL, where to save this data, whether we want to compress it or not, all those things. And we don't even write new code when we create a new pipeline. We just write those specific configuration to make it work this time. Also, we're using small functions, which is also a feature of Vertex Kubeflow pipelines, and you just wrap some function with a decorator, and it creates a container for you. So that's another thing. And sometimes you do need to do some things specifically, but as you can see from the whole pipeline, which is pretty big, only those two orange ones needed to be write specifically. So as you can see, a lot of reuse over here. So as I can tell you, this is working pretty well for us. We talked about those standard ops. We talked about cookie cutters. We talked about those pipelines and all those different ways to build something that can be reused and which is simple in the engineering side, to leave us all the room to do data science as we would like to. We still know there's a long way ahead, but I hope that if you guys are working with data science teams, you can take at least some of the tools, the values of the things that I presented and try to implement it with the data science team, because it's already very complex and it's very hard to take machine learning models to production. So I really hope that's going to be helpful for you guys. So thank you very much. If you guys want to be in touch with me, I have a LinkedIn and a Twitter account and a few links if you want to look at the different libraries that I used. And if there's some questions, I'm happy to answer them.